Welcome dear all in my YouTube channel Elexys project, and today we will see a new hardware setup. Title name is automatic power factor correction. So you can see all the components right here. So we will see all the components one by one. So here you can see we are using some capacitors to improve the power factor. Whenever it needs, automatically it will turn on according to the requirements. Okay, and a relay module, to channel relay module. Okay, it is used to turn on of these two capacitors. If suppose this one is needed, it will turn on from this relay, and this one needed turn on from this relay. Okay, next component we can see is one using one current sensor here to measure current signals. Okay, current ratings, or you can say current signals. Okay, to check what is the current angles. Okay, to measure the power factor. Okay, and accordingly we will perform the operation. And next component we can see we are using one ESP8266 module. It is actually the brain of the system. Okay, you can say heart or brain. Okay, and it is responsible to handle entire operation like running LCD and operating Wi-Fi operations and all the turning on and off the nodes. Okay, all this performed by this ESP8266 module. We can see we are using one screen cost LCD. It will show our power factor value and corrected power factor value. Okay, we will see each and everything one by one. We can see. Okay, we are using one large 4-channel relay module to turn on of all these loads. Okay, so you can see it is 4-channel relay module. It has a 7 ampere rating and 230 volt power supply. Okay, and 5 volt operating range. And next component we can see we are using multiple lamps. Okay, as a load. So you can see it is actually purely resistive load, and these all have some electronic circuitry inside it. So we cannot say it is purely inductive load or resistive load, but it is nearly resistive loads. Okay, this is also okay. You can also read here tags. And next we can see we also have one inductive load. Okay, as you know, on the inductive load power factor is poor. Okay, so we will see effect of each load on power factor. We have wirings. This module is used to this adapter is used to provide a 5 volt power supply to all the systems. Okay, 5 volt systems. Okay, and this cable is used to provide 230 volt to turn on and off the loads. Okay, so let's connect both to the extension board. Connected both of the loads. Okay, so let's turn on the load. It is turning on right now. See, home automation with automatic power factor correction. Okay, you can see current power factor is 0.99. Okay, power factor is 99 and correction is 00. Okay, you can see. So we will need to turn off all these layer loads from the app. Okay, this is the Android app. Okay, so project has successfully turned on, and we will use this cell phone to turn on and off the loads. As this project is IoT enabled, and it has the ability to turn on and off the loads using a distance, as like a home automation project. Okay, so you can see currently it is showing power factor 0.99. Also we can see power factor and all the thing here. Here is the power factor, here is the correction. Okay, and all the loads are currently off. You can see. Okay, all the loads are off. So let's see. We will turn on first load by this resistor load using this button. So you can see first of our load has turned on, and you can see power factor is currently still to the 0.99, and you can see power factor was corrected by 0.02. Okay, only. Okay, let's turn on second load. See, second load has turned on here. Okay, and you can see all the data on LCD and as well as on the app. So you can see power factor is corrected to 99, and power factor correction value was 0.04. Okay, you can see same on the app and on the screen. Okay, so let's turn on third load. Third load is also nearly resistive load. See, you can see it is turned on, and it has higher ratings. Resistive load, so you can see power factor is still 0.99, and you can see correction factor is 0. Corrected value is 0.09. Okay, but this is the inductive load. Okay, as you know, inductive load creates a lot of problem in power factor correction measurement, or you can see lacks current angle to voltage angle, okay, more compared to resistive load than inductive load. So you can say transformer inductive load. So I will turn on this load. See, transformer is currently on now, okay, and you can see corrected value was 19, okay, and power factor is automated to 0.99 and correction was 0.19, okay, power factor. So you can see all the loads are on. So I will turn on the same inductive load first. So we will turn on this one. So you can see lamp has turned off, and you can see correction value is 0.14, okay, and power factor is 0.99, correction value was 0.14. Okay, let's turn on this inductive load. So you can see both of the capacitors are on. You can see from here this red light indicates which capacitor is connected with parallel to the line. So you can see, okay, and here on the load side also. Okay, so let's turn on inductive load. See, inductive load has turned off, you can see, and you can see power factor correction was 0.04 only, because these are only resistive loads. Okay, you can see I'm gonna turn on this load. See, already the resistive load is on, so you can see 0.9 and power factor correction of 0.02 only. Let's turn on second load. Okay, so in this case you can see one power factor, only one capacitor is under the line. Okay, this one is off, this one is on. Okay, let's turn on third one. So you can see now this side capacitor is on now. This one is turned off to maintain the power factor. Okay, let's turn on all the loads. See, 0.19 and power factor is 0.99. You can see both of the capacitors are connected in parallel to maintain the power factor. Okay, so let's turn on all the loads. See, there is no load on the line, that's why power factor is 0.99. Okay, no correction is there, only inductive load is there. So you can see 0.10% is in correction, okay, and power factor was maintained to 0.99. Okay, once again turning on all the loads. Okay, turning on off the loads. Okay, so thank you so much for watching this video. And see, once again, if any student want to make a home automation with automatic power factor correction, so this model is also suitable for all of them. And if any student want any other kind of project, please visit our YouTube channel and go to playlist, and you can see there are so many models available on the YouTube which is suitable for your college submission. And thank you so much for watching this video.